Tes, tes, halo, tes, 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 tes. Tes, 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 tes. Udah kedengeran ya Pak? Udah ya? Kakak-kakak S2 yang bergabung, halo, bisa dengar suara saya dengan jelas nggak ya? Mbak Tati, bisa dengar suara saya dengan jelas, Mbak Tati?
Bisa, bisa dok.
Jelas, Bu.
Mas Damas, bisa dengar suara saya?
Ya, jelas, Bu. Siap.
Ini kalau ada pertanyaan, jangan malu-malu tanya aja ya. Nggak usah ragu-ragu, bahasa Inggrisnya dangdut. Tes. Cek, satu.
Ya, masuk, Ibu. Siap.
Pagi, Mas Damas, Mbak Tati. Kalau sekarang sudah bisa dengar belum suaranya?
Siap, jelas.
Ya, sekarang sudah dok.
Nih, Mas Damas sama Mbak Tati bantu kita. Oh jelas, kata Mas Damas. Jelas Pak katanya. Kamu ini jelas Pak katanya. Nah, Mbak Tati dan Mas Damas boleh coba ini nggak? Halo-halo dulu nggak? Soalnya kita belum dengar suaranya nih.
Kita dia
Eh,
tadi ngomong dok.
Kita belum bisa dengar suaranya Mas
Oh
Damas dan
enggak.
Mbak Tati sebentar ya. Akan
Oke.
coba di figure out dulu. Iya, tidak tidak masuk Mas Damas. Ini lagi sedang diusahakan ya. Nanti izin Mas Damas dan Mbak Tati membantu kita dulu untuk cek sound ya. Supaya sebelum pembicara dari NTU-nya datang, udah set up semuanya sound system.
Tes, cek, 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 cek.
Hello, good morning. Hello, good morning. I cannot hear you, Fatima.
Good morning.
Okay, I can hear you now.
I think
Oh, I
Dr.
lost.
Fatima not yet.
I see. Okay. I still cannot hear. Sorry. Hello, we cannot hear the voice.
Oh, yes. Maybe I can. Oh, what's
Hey, I received the message. Just let me know when I need to start. Thank you. Hello. Hello, Fatima.
Hi, Taresha. I'm sorry, we're still.
It's okay. I can hear you now. Are we doing through the individual now?
Can you wait a minute? I think I will just erase
I can
my.
share screen also if you want to. I have the slides with me. It's okay.
Yes, okay. We
Do
can
you want me to load? Maybe I'll try sharing my screen, yeah?
Okay.
Can everyone see the slides?
Yes, we can. We can see it
Okay.
clearly. Okay.
So should I start now?
Okay, so the thing is because the students who can see your slides is just those joining online, and we have like a bunch.
Yes, that's right.
I think more than 60 students. I think more than
Yeah.
60 students that haven't joined online because they are really
Yeah.
hoping to see your lecture from the big screen in our auditorium.
Yeah, it's okay. I can wait. You've received my slides last night. Do you want to load it also in the auditorium? We can do
Okay.
that also.
Okay. Okay. I think I have to make the call. So like if we cannot, if the things they'll do not work in 5 minutes, then
Yeah.
that we will start by tuning in from individual laptops.
Okay, sure. Okay, let me know. So I'll just keep it on standby.
Okay.
When you
Okay.
want me to start, you just let me know.
Okay.
I'll keep my microphone in
And we are
silence.
truly apologize for
It's
this.
okay, don't worry at all. It's the teleconference is always difficult.
Okay, because when we do try out of our sound system speaker last Friday, everything works well. And then the
Okay, I
weekend,
blame it on the Singapore Singapore connection.
yeah, and then the weekend happened, and then today it just
Oh
didn't.
yeah, the lecture theater does not want to wake up on Monday morning.
Okay, we truly apologize, and I think I will need to discuss this with our vice dean because our vice dean is already here as well in the room.
Yeah, okay.
Uh,
So should I stop share so that Baisin can give a talk? Maybe let's stop sharing.
No.
Oh,
Maybe you can share your first screen so the one joining us online will know that
okay.
things will starting soon. But I will just need
Okay.
5 minutes to talk to the vice dean. Okay, and we will make the decisions after I consult to the vice dean, who is
Okay.
actually already in this room. Okay. Okay. I'll talk to you soon. Kenapa?
Kalau mau ngasih sambutan dari sini nggak apa-apa.
Oh, gitu.
Bawa aja laptop aku dulu ke sana.
Boleh.
Gampang lah daripada nggak mulai-mulai, Pak.
Apa sambutan dulu gitu ya?
Iya, itu sambutan dulu baru.
Tapi dari laptop masing-masing nggak sih? Tes. Oh, bisa. Tes. Oke. Hai.
Don't worry, I'm trying to do some work in parallel. Sorry. Hello. Hello.
Tes, 1, 2.
Hello. Hi, I can hear. Hello, Fatima. Should I start now?
Bisa mulai kan? Ini sini Mas.
Nah, adik-adik kita mulai sekarang ya. Semuanya udah pada online ya. Bisa angkat tangan nggak? Kasih jempolnya nggak kalau udah online? Udah ya. Perlu dikit. Yang lain udah bisa online belum? Valerina, kamu belum bisa online. Nunggu link ya? Oh, linknya ada yang ada di gambar poster. Nggak bisa dibuka.
Udah
Oh, udah.
share yang
Nggak bisa connect.
udah aku share lagi.
Oke. Maaf. Siapa aja yang belum bisa join? Tina belum bisa juga. Oke.
Oh, 76 participants.
Kalau gitu saya izin mulai dulu juga ya, semua proses.
Should I start?
Test. Hi,
Yes,
Teresia.
I can hear you. Yes,
Okay, can you hear my voice now?
yes.
Okay. Everybody, guys,
Ini kan mau saya
we will start soon.
baru saya
Can you please be quiet?
karena ini PGA. Jadi kalau ini kan adanya HDMI Bu, jadi nggak cocok.
Okay. We will truly start now, and I hope that you can tune in and pay attention closely to the guest lecture, okay? Can anybody hear my voice without the microphone? Can everybody hear my voice without the microphone? Those who sit in the back, can you still hear my voice clearly? Okay, okay, then we will start now. Teresia, we are so sorry. We are truly apologize that this inconvenience happened. It doesn't, well, it shouldn't be this way. We already do a check sound test on Friday, and things work perfectly well. But now when we need it the most, things just happen.
It's okay.
So
No problem. Let's carry on.
Okay. Thank you very much for your understanding. And yeah, we are actually so excited. We are very happy to joining you here. I would like to say good morning and welcome to everybody, and also those who joining us online. It is an honor for us to have Dr. Teresia Mina here with us today. And I would like to also say hi and welcome to the Vice Dean of Faculty of Public Health UI, Ibu Asistiarini, who has been here with us in the auditorium, and also fellow lecturers and staff at the Department of Public Health Nutrition. We have Bu Arifah here, and also Mak Puput, Mak Novi, thank you for being here with us today. And also, of course, I would like to say welcome to all of you, students of the Bachelor of Nutrition program at University of Indonesia, and those from the postgraduate program who are joining us online. So we are gathering here to listen to the guest lecture from Dr. Teresia Mina. And this is actually the first event, the first guest lecture of the guest lecture series that we have prepared this year from the Department of Public Health Nutrition. So this year, we raised the theme of unraveling issues related to obesity, because we see that out there, nationally in Indonesia, the burden, the public health implication due to obesity is becoming more concerning. The recent trends and also updates from the international scientific point of view related to obesity. So thank you. And before we start the lectures, I would like to invite our Vice Dean, Ibu Asistiarini, to give her short opening remarks and to open this event officially. So Ibu Asi, please come up to the stage and the time and place is yours. Gak bisa Ibu. Saya kayak ini aja Bu langsung. Yang ini dengar ya.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Good morning, everyone. The Honorable Dr. Teresia Mina is a Senior Dean's Fellow at Nanyang Technological University, Likong Chiang School of Medicine, Singapore. Also, the Honorable Ibu Siti Arifah as a Secretary of the Department of Public Health Nutrition. Ibu Dr. Fatimah Sikit, PSD, as a lecturer, and I think we also have another lecturer here from Department of Public Health Nutrition Faculty of Public Health Universitas Indonesia, and all of the students. On behalf of Public Health Faculty Universitas Indonesia, I would like to thank to the Department of Public Health Nutrition for coordinating and organizing the Stadium General with the theme of unraveling current issue related to obesity. I would like also express to my gratitude to Dr. Teresia Mina as a Senior Dean's Fellow at Nanyang Technological University, Likong Chiang School of Medicine, Singapore, who was placed to give a lecture regarding the impact of adiposity on cognitive function. As we know that Indonesia now still also a triple burden malnutrition. We're still facing with undernutrition, overnutrition, and also micronutrient deficiencies. And we know that the data from the research dasar national saw that the prevalence of obesity was increased from year to year. So I think we need to learn everything about the obesity to prevent and address this.
I think the connection is, I think there is some,
Yes, I think so.
hello. Hello, Fatima.
Okay, thank you very much, Ibu Asistiarini, our Vice Dean at Faculty of Public Health, for her opening remarks and also that opens this event officially. Thank you very much, Ibu. And now, before we listen to the lecture by Dr. Teresia Mina, let me read aloud her short bio for a bit. Main interest is to investigate okay, so Dr. Ter is a senior dean fellow at Nanotechnological University. She graduated from her PhD degree at the University of Edinburgh investigating the intertwining relation between adiposity, brain and cognitive functions, and also eating behavior. And beside her work at NTU, Dr. Teresia Mina is also one of the leading editors in the world-renowned Frontiers in Nutrition journal. So without further ado, I would like to give the opportunity, the time and place to Dr. Teresia to start your lecture. So in here, in the auditorium, displaying your lectures in the big screen. And we can hear your voice as well clearly because they're individual devices. So Dr. Teresia Mina, can you hear my voice?
Yes, I can hear
Okay.
you. Yes, okay. So I
Okay,
shall
thank you
start
very much.
now.
Yes, okay, go ahead.
Okay, so if there is any problem later, just feel free to interrupt me. So my lecture should be about half an hour or so. And then I'm more than happy to take a question in between, but if you want to keep all the questions towards the end, I'm fine as well. Okay, selamat pagi, everyone. Good morning and greetings from Singapore. Thank you very much for the kind invitation and for the very generous introduction. Without further ado, let us start the lecture. So I do understand that you are from the nutrition, so you may be, this is related to the obesity, but I'll be sharing a little bit about cognitive function and some probably new concepts on genetic analysis. Please do bear with me and you can take note of any questions and we can discuss that later. Okay, so this work was published almost, I think, about 2 years ago. But at the point of the analysis, the main motivation for conducting the analysis for undergoing this research was twofold. The first one was that we know that the baseline cognitive function at adulthood could contribute towards pathological cognitive decline. So the figure that you see on the left was taken from the Mendelian randomization studies of an international studies, looking at the causality between cognitive function and Alzheimer's disease, which is one of the cognitive decline. And you could see here, for example, the years of schooling, which is the levels of education, and then at the bottom, the intelligence or the cognitive function. So you could see the dot on the left, and it means that the higher the cognitive function of an individual, the lower the risk of the individual for developing cognitive decline. So cognitive function is important. On the other hand, on the right-hand side of the slide, you would see another forest plot taken from the meta-analysis and systematic review investigating the relationship between metabolic syndrome and cognitive decline. You could see at the bottom of this diagram, if you see my mouse here, you could see that the overall conclusion of this meta-analysis is that there is a causality between metabolic syndrome or cognitive decline. But this is not a very good meta-analysis because you would see there is a lot of heterogeneity in the evidence indicating that although there is a link between metabolic syndrome and cognitive decline, there is a need for further study to investigate which part of the metabolic syndrome that contributes to the cognitive decline. Is that the hyperlipidemia part, or is it the hypertension, or is it the other components? And that is what we should like, or my study investigated. So the knowledge gap was that we do not quite understood at the point of the analysis which metabolic risk factor confer independent adverse effect on cognitive function. And we also do not quite understand whether there is causal relationship between excess fat or adiposity with baseline cognitive function. We therefore hypothesize that excess adiposity is the key metabolic factor affecting cognitive function. And in order to address the hypothesis, we employed two strategies of the analysis. The first one is the epidemiological analysis of the multi-ethnic Asian population using the Helios study in Singapore as a representative cohort. Helios stands for Health for Life in Singapore. And this cohort comprises individuals of Chinese ancestries, Indian ancestries, and Malay ancestries that are similar to Indonesians as well as ethnic others, all living in Singapore in shared environment, otherwise going through the same environmental exposure. So the epidemiologic analysis were undertaken in several levels, the univariate levels, the multivariate levels, as well as the sensitivity analysis. The diagram at the bottom shows you the age distribution of our Helios study. This is the adult cohort. So you could see that we enroll participants from age 30 and beyond. So there is no teenagers, there is no pediatric population, and we also excluded pregnant women. So there's only adult non-pregnant individuals. All Singaporeans citizens as well as permanent residents were welcome. As you may already know, there are many people coming from different countries who decided to stay and live in Singapore. Now, the second part of the analysis, which is to explore causal relationship, use the strategy of two-sample Mendelian randomization. Similar to the epidemiological analysis, there was the main analysis part, and there was also a sensitivity analysis to test the robustness of the findings. So a little bit about the methods that we use in the Helios study to measure first the outcome of interest, which is the cognitive function, and the exposure variables, which is the body fat or adiposity. Let's start with the cognitive function test first. So we employed a computerized cognitive function test. This was compulsory to everyone, to all the participants, as long as they were able to use a computer. And the test comprises several domains. It covers memory, executive functioning, processing speed, and attention cognitive domain. So our cognition are divided into several domains. This was modeled after the similar test that was also employed in the UK Biobank to ensure the intra-operational operationality of our data, so that if we were to perform a meta-analysis using UK Biobank data, which is by far one of the largest study, we would be able to do so. Now, from these several domains, each of the domain gives a score. And within each domain, sometimes there are 2 or 3 different tests. So this is not an IQ test, it's a very brief cognitive function screening test, which is about only 15 to 30 minutes. So for young individuals like you, I'm very sure you could complete this test within 10 minutes. But for our older individuals, aged 60s and above, it took them a bit longer. Sometimes it could take them up to 30 minutes. The way the test worked was that if you were unable to answer several questions or made several mistakes, it would be immediately it will be immediately stopped. So then there are the good distribution of the scores. Now, from this test, we then derive what we call as a G. G is a composite score of the general cognition. It's not the same with IQ, but it encompasses the overall cognitive function of an individual. This is derived from a principal component analysis. Now, I should like to now shift your attention to the methods that we use to quantify body fat composition. So in the Helios study, we use the general anthropometric, including the general height and weight measurement, waist and hip circumference measurement. But we also employed a state-of-the-art imaging technology, which is dual X-ray absorptiometry, or DEXA in short. So the DEXA scan is usually used to inform you of the bone mineral density, but the whole body scan also provides information on muscle composition as well as body fat distribution. And so this is what was used in this analysis. Now, the body fat was quantified using a whole body DEXA scan, and of particular interest in this analysis is the visceral adiposity. If you look at the diagram, visceral adiposity was estimated using a different contrast of the individual image. So estimated visceral adipose tissue, or VAT, equals total fat in the lumbar fold region minus subcutaneous fat in the lumbar fold region, so that we will only end up with the region at the middle. And then similar to the body mass index, this estimated visceral adipose tissue is in mass unit, is in grams or kilograms. So you would appreciate that everybody comes with different height. So just because they have the same amount of mass doesn't mean that the fat mass index would be equivalent. So it is important, just like the BMI, to normalize the fat mass with individual's height. So we derive the same formulation, just like a BMI, fat mass index equals total fat divided by height squared. So using this approach, we could derive several fat mass indices from across the body fat depot, including total fat, visceral fat, fat in the arms, legs, limbs, endoid region, gynoid region, the total limbs, which is a combination of the arm and legs, and trunk. We also then compare with conventional anthropometric indices such as BMI, waist hip circumference. And you may have already heard about the waist hip ratio. So similarly, we could also derive several fat distribution ratio. Each of them could inform us on a different aspect of fat distribution in our body. So we have android gynoid ratio, trunk limb ratio, and ratio of the visceral to total adiposity. Okay, I'd like to briefly introduce you to the concept of Mendelian randomization. So as a students of public health, I'm sure you have heard about the randomized control trial and the so-called pyramid of evidence, which is what you see on the left-hand side of the diagram. In a typical pyramid of evidence, the top is a systematic review of the randomized control trial, which is meta-analysis. Now, then you have randomized control trial, followed by Mendelian randomization, and finally cohort or case control or observational studies. So the higher we go to the top of the pyramid, the stronger the evidence of the causation. Mendelian randomization lies somewhere in the middle. So it's not really a cohort study, but it could fully utilize the large genomic data that have been collected by other countries in other parts of the world. So how does this then work to help us prove causality? If you look at the diagram on the right, there are three general assumptions of Mendelian randomization that we need to fulfill in the analysis, and this is important. Now, I inserted the visceral adiposity, which is the outcome, which is the exposure of interest, and the general cognitive function, which is the outcome of interest. The first assumption is that the genetic variance must be associated with the modifiable risk factor, which in this case is the visceral fat. The second assumption is that the genetic variants are not associated with any confounders, because if they are associated with other confounders, such as height or maybe blood glucose, then the causality does not come from our exposure of interest. The third assumption is that the genetic variants influence the risk only through the risk factor and not through any alternative pathway. So the overall take-home message is that if we were to prove the causality that visceral fat affects the general cognition, then the genetic variants that are associated with these two traits must lie together. Okay, so this is the so-called very generic workflow of the typical Mendelian randomization analysis. The first one is that, first of all, we need to extract the single nucleotide polymorphisms information of our traits of interest or exposure of interest. These are available from a publicly available database such as the mrcieu.ac.uk, which were established also by the UK Biobank. So we extract these so-called summary statistics of the exposure, do the same with the outcome variables. We then harmonize the allele. Harmonization is important. If you recall the concept of the DNA, which is a double helix, is that the strands must align together. Otherwise, it would be the opposite strands, and that would create a confusion. The harmonization stage is important. And finally, then we do the two-sample MR, which is done here in my case to use R, but there are other statistical tools that you may use as well. And Mendelian randomization is essentially regression analysis, just like in a typical classic epidemiological analysis. It's just a regression analysis on a lot of single nucleotide polymorphism. Now, the table on the right summarizes the exposure variables that we were interested in, the outcome, which is in bold, which is cognitive performance. And just like a typical experiment, you do need a positive control to ensure that to help us interpret the results. Now, in our analysis, we were not only looking at the visceral fat, but we also wanted to employ the concept of metabolic syndrome. Recall that the metabolic syndrome has several components, and we do not know which of the components confers a causality on cognitive performance. Hence, we included not only the visceral fat, but also the BMI, waist circumference, waist hip ratio, blood pressure, lipid profile, and glycemic indices, including glucose and HbA1c. And again, recall, by the time I arrived at the 2-sample MR, all of this information were not from the Helios study, but from publicly available GWAS summary statistics. As you could see here, all have been published, all available in the public domain, all come from a very large studies, and all come from an international consortia, because in the context of the GWAS, it is important to obtain the summary statistics from as large study as possible to ensure a statistical power. And at the end, at the right-handmost column of this table, you will see that after clumping and the harmonization, here are the number of the SNPs that are shared between the exposure of interest and the outcome. You will see that there are different numbers. You will see that some have more SNPs, some have less, and this may affect the results, as I would explain later on. Okay, so let us review the results of the findings of the epidemiological analysis first. So what you see on the left-hand side is a volcano plot. On the x-axis is a standardized beta of the z-scores of all our exposure variables, and the y-axis is the minus log p-value. So you would see so-called a volcano shape. On the right-hand side of this diagram, it means that the higher the, let's say, for example, HDL, the higher the cognitive function. And then on the other side of the diagram, let's say, for example, the higher the visceral fat mass, the lower the cognitive function, because the standardized beta is negative, okay? So you would see here all the expected association. For example, the higher the score of the continuous metabolic syndrome, means the higher the number of your metabolic syndrome score, the lower your cognitive function. This was consistent with the findings from the meta-analysis that I cited earlier. But similarly, the higher the waist hip ratio, the higher the fat, all of these were fat. They are all on the top of the diagram, the lower the cognitive function. So the take-home message is that excess adiposity, in particular excess visceral adiposity, were associated with poorer cognitive function. Of course, we adjusted for the multiple testings because you have many associations. We adjusted for sex, age, and ethnicity, and this was done from the Helios data, n equals 8,769 individuals. Now, this is fine. We see a lot of significant associations above the p-value cutoff, where blue indicates significant associations. The only one that is not significant is the LDL. So what's next? How do we find out which is truly independent effect, or which of the associations are truly independent? And we do that by moving from the univariate association analysis to the multivariate association analysis. I've also performed a dimensional reduction using a hierarchical clustering. So then I selected representative variables. There are still more than one variable, so multivariate regression was still necessary. Now let's move on to the multivariate analysis. On the left-hand side is a heat map. So this heat map indicates the strength of the association. So let me orientate you through this heat map. You will see on each of the row here, these are our exposure variables of interest. Remember that the outcome variables were the cognitive function. So what does each of these columns tell us? So each of these columns is one multivariate models. So you would see here, the redder the color, the more positive the association, the bluer the color, the more negative the association. So in this multivariate analysis, you would see that visceral fat is an independently associated with cognitive function, independent of blood pressure, independent of HbA1c, independent of HDL. The same goes for the waist-hip ratio, but not waist circumference and not BMI. So what I did for each of these columns was to emulate the concept of metabolic syndrome, because within each individual, you don't only have hyperlipidemia, but some individual will come up with somehow suboptimal blood glucose, somehow suboptimal HbA1c, suboptimal fat. So what we want to know is at the multivariate levels, which of the risk factor confers independent effect. And this is, and again, the conclusion remains the same, which is that excess adiposity, in particular visceral adiposity, were independently associated with poorer cognitive function. Sorry. Okay, now, so then we have gone through the univariate association analysis. We've gone through the multivariate results. The results are so far so good, consistent with the findings, and also show us that visceral adiposity plays an important role in cognitive function. Okay, that's fine. But then how do we translate this concept into the cognitive aging? Because sometimes it's easy for us to say, yeah, so the cognitive function is affected by fat and fat is bad, but to what extent? How do we quantify it? So in the world of the cognitive realm, sometimes we use the concept of cognitive aging, because it then gives us the unit of years to say, for this amount of fat or for this amount of adiposity, there is a potential aging of how many years in terms of the years. And this is important because Alzheimer's disease or cognitive decline affects the geriatric population. So what we do here is still using the same underlying Helios data, and is still doing the same association analysis using an epidemiological analysis, but instead of the G, we use the cognitive aging. And cognitive aging was derived by dividing the beta association for each risk factor with the beta of age. Remember that we adjusted for age, sex, and ethnicity. This is perhaps statistically a bit too complicated. Very happy to come back to this later. But the take-home message from the forest plot that you look on, that you could see on the right-hand side of the slide, is that the higher the waist-hip ratio, the higher the waist, the broader the waist circumference, the more fat, the higher or the greater the cognitive aging. On the other hand, the higher the HDL, the lower the cognitive aging. This is consistent with our understanding because HDL is known as the so-called, colloquially known as the good fat. So the left-hand side of the forest plot was taken from the Helios study. We did not want to stop there. We did have access to the UK Biobank data, and we wanted to compare and convince ourselves whether findings from the Asian population can be reflected at the global population as well. So we used the UK Biobank data, which are mostly European, people of European ancestries. We did the same analysis, we ran the whole analysis again, but using their data. And then you could see that the findings were in fact very similar. The more the fat, the higher the cognitive aging. The more good fat or HDL you have, the lower the cognitive aging. So this was a very happy result for us because we could see that our findings are not relevant only for the Asian population, but also for the global population. Okay, so far so good. The epidemiological analysis was satisfactory, but this is just a cross-sectional study. This is an association as a cross-sectional level, and therefore is not enough to prove causality. It's not enough to prove that A causes B. And causality is important for disease prevention. because if we know there is a causal evidence, we can then go back to the risk factor and address that risk factor to mitigate the health problems of interest, right? Now, this is where the two-sample Mendelian randomization comes, because using the genetic instrument that is universal, we can then determine whether there is a genetic predisposition between the exposure of interest and the outcome of interest. Okay. Again, so what you see here is a forest plot. There are three forest plots, the three panels. Each of these panels refers to a different methods of Mendelian randomization analysis. These are three very common Mendelian randomization analysis methods: inverse variance weighted, Emma-Eager weighted median. Now, don't worry. Let me orientate you through this complex diagram. What you see in the x-axis is similar to what you've seen in the volcano plot in the previous slides. So these are beta, so these are association. Recall that I mentioned earlier, Mendelian randomization essentially is regression analysis, but instead of using public health data, we use instead of using public health data, we use genetic instruments. Oh, why is there some scribbles in the diagram? I'm not quite sure where this is coming from. Okay, it seems to be staying there. Never mind. Let's carry on. Now, each instrument outcome here, the instrument outcome is the general cognition, and each row is the instrument exposure per one Mendelian randomization. Recall that what I was doing here was trying to emulate or repeat the analysis again, but instead of using public health data, I use the genetic instrument. So the arrangement of the exposure variables were the same. The definition was the same. Visceral adipose tissue derived from DEXA, the BMI, waist hip ratio, blood pressure, etc., all within the concept of the metabolic syndrome. But what you're looking at now is not public health data, but it's a genetic instruments data. Okay, now you would see here that anything that is essentially falling within the dotted line means that there is no significant results. There is no causality. So there is no causality between blood pressure, lipid, and glycemic indices with cognition. Now, I would like to bring your attention to the one at the bottom first, because if we start with the bottom, you would understand what the MR is, okay? So here is education level. We know from the literature that education levels are causally linked with cognitive function. The more educated you are, the higher your cognitive function. So education does have a protective effect on the cognitive function. So you would see here, the higher the education, the higher the genetically predicted education level, the higher individuals' cognitive function. So that is why you see at the right-hand side of the diagram, okay? So these are our positive control, and this will help us to interpret the diagram on the top. Now, pay attention to the VAT, or visceral adipose tissue, BMI, and waist hip ratio, because they are these only three risk factors that confer a causality, whereby the genetically predicted greater visceral fat, or BMI, or waist hip ratio, the lower the cognitive function, because they are at the left-hand side of the diagram. Okay, so that's inverse variance weighted, the same story as seen in the weighted median. This is essentially the same, using a different technique, but the same concept of analysis. So what the MR does is that if you employ several different strategies of analysis and come up with the same result, that means your results are robust, okay? Now, the MR-Eager at the middle panel is slightly different. This one is telling you, in fact, in here, if we see all at the left-hand side here, along the dotted line here, it means it's a good thing, because MR-Eager represents the heterogeneity of the analysis. It means that there is no significant heterogeneity in this analysis, which is good because when you have heterogeneity in the MR, it means that your results are unreliable. Okay? All right. So you would imagine that if there is a genetic variance that predict visceral fat or genetic variance that predict higher BMI, perhaps this genetic variance may also overlap with other metabolic traits. It may also predict other metabolic traits. So in the Mendelian randomization analysis, it is important that we take into account the effect of pleiotropy. So pleiotropy means that we need to only focus on the genetic variance that predict only that particular outcome or exposure of interest. Meaning, if I have 1,000 genetic variants or SNPs that predict visceral fat, I need to be very sure that this 1,000 genetic variants predict visceral fat only and not other metabolic traits, because I'm trying to prove the causality between visceral fat and cognitive function. This is where you come to see this so-called colorful diagrams, because using the publicly available GWAS catalog, we can see whether we can check whether one single nucleotide polymorphism predict one phenotype only or many different phenotypes. And we need to get rid of those phenotypes that we need to get rid of those variants that predict multiple phenotypes. I only want the variants that predict single phenotype. So this is part of the sensitivity analysis for the Mendelian randomization. After checking against the catalog, I repeat the entire Mendelian randomization analysis again. And then as you can see here on the right-hand side, the same inverse variance weighted MR that what you have seen in as what you have seen in the previous slide, but with a narrower list of genetic variants. So the genetic variants have been further cleaned to address potential pleiotropy. And much to our happiness and satisfaction, the result was robust. You would see that the higher the visceral adipose tissue, the lower the cognitive function. Similarly, the higher the genetically predicted BMI, the lower the cognitive function. Somehow, the weight-hip ratio did not survive the sensitivity analysis, which is okay. In research, that is why we do the sensitivity analysis. Sometimes some of the exposure survive the sensitivity analysis, sometimes they don't. And that's the findings. That's okay. Okay, so just kind of to bring together all this plausible biological mechanism, because if you think about it, how can a fat in the tummy affect how your brain function? Anatomically, it's quite distant, isn't it? One is in the tummy, the other one is in the brain. Well, in fact, the visceral adiposity do have many different kind of mechanisms through our circulation that could then affect how our brain functions. So here are some of the review of this. Of course, these were not done by me. These were studies that are done by other people, but these are mostly molecular type studies that were done in other contexts. So for example, visceral fat, the higher the visceral fat within the individual, the greater the physical compression that it exerts on the kidney. And so this will then activate the MR or the mineralocorticoid receptor. And this affects, in a nutshell, how the kidney functions. And this is how visceral fat could increase the blood pressure. And when the blood pressure was raised, this will create endothelial injury, including in the blood-brain barrier. So there has been several molecular studies that demonstrate this. And visceral fat is really the bad guy because it exerts so much different systemic effect. It compresses the kidney, it increases pro-inflammatory cytokines, leading to insulin resistance. It disrupts the homeostasis of the lipid, LDL and HDL equilibrium, which means this will also disrupt whatever lipid that is circulated to the brain. And it also creates an imbalance in the adipocytokines, which you may recall are cytokines in the body, and that also could have effect on the synaptic plasticity in our brain. Okay, so these are some of the potential biological mechanism of how fat, despite being anatomically so far from the brain, could affect how our brain function. So there was no such thing as a perfect study. Each study always have a limitation. The limitation of our study was that the associations might be a byproduct of metabolic diseases. Well, okay, because in our cohort, we do have people who already come with statin, who already come with a diabetes. So how do we adjust for it? So of course, we had the sensitivity analysis that I didn't share in this result due to the limited time. But one way was to then say, if I repeat the analysis, remove all of these people that already have a disease or have medications, would the results still be the same? The results was very much still the same, because here is the entire data set results, which you have seen in the earlier slides. And here is the result when repeated in a subset with no medication. There was a shift. There was a reduce in the statistical power because of the loss of the sample size, but it was still significant. The results were still the same. The conclusion remains the same. Okay, our Helios study cohort is a cross-sectional cohort. Cross-sectional analysis may limit us in the extrapolation of cognitive decline. I have mentioned that what we measure is a cognitive function from the computer test when our participants come to our study center. This was at that moment. So we don't know whether that cognitive function would then affect how the individual progress in their cognitive decline. We cannot know because this was just an assessment done at that time. But we do rely on the literature evidence that has already shown that cognitive function of an individual does posit risks, or that does influence the individual risk of developing cognitive decline. Yeah. Another limitation was from our MR analysis. The publicly available summary statistics of all of these GWAS studies cannot address participant overlap. So unfortunately, the way the big consortia work is that a consortia in the United States share data with consortia from the United Kingdom. So one of the important MR assumption was that there should be as little as possible of a participant overlap. But the way the consortia work is that sometimes there are some participant overlaps. There's not much I could do at my end because I don't have access to the individual data. I only have access to the summary statistics. So that is why the sensitivity analysis that we do was important to reduce the bias and the limitation of the MR analysis. Our study also has strength. The strength is that we are not just stopping at the epidemiological analysis, but we try to incorporate the genetic component and try to increase the evidence for the causality. The Helios cohort is very unique. It involves the understudied individuals, which includes individuals of Southeast Asian ancestry, Malay individuals, Indian individuals, Indonesian individuals. There were many actually in the cohort. The Indonesians who have already migrated to Singapore and stay in Singapore, live in Singapore. And we were not just using BMI. We use image-based, DEXA-based whole body quantification of adiposity. This enables us to look at different adiposity results. And our population is a general population. This was not population derived or recruited from the hospital or from the clinic. People were relatively younger. These are working age adults, people who are still healthy and technically haven't had Alzheimer's disease yet. Yeah. So there are chances to prevent the disease, and this is what makes our cohort special. Okay, so here's the conclusion of the study. Excess adiposity is an independent and causal determinant of cognitive function in Asian population. And prevention of excess adiposity could help maintain or improve cognitive function. And given the rapidly rising burden of obesity in Indonesia, as well as across the Asia Pacific, our findings do have an important implication for global health. How? Because if you address the adiposity or reduce the adiposity, you could probably resolve two global health problems. first is the adiposity, obesity problem, and the second is the dementia problem. So you kill two birds with one stone. So I think that's the important kind of message from the study. Now, I would like to just share a little bit more about our ongoing work. Our work does not stop there. Our story does not stop there. Here are two medRxiv work. This is publicly available preprint of our work, meaning that we have already completed the work. This is currently being submitted to the journal, undergoing a peer review process. But for those of you who are interested, I would like to encourage you to visit this link and explore a little bit more about our work. I'd just like to give a very quick overview of the one on the left, which is the adiposity and metabolic health in Asian population. So using the same technique, but a little bit different analysis, and which I think would be more relevant to public health nutrition. Now, I'd just quite like to share the first one is that we look at this cohort, we look at our cohort, the Helios study cohort, and we look at the odds ratio of metabolic diseases, diabetes, hypertension, and hypercholesterolemia across ethnicity, okay? And unfortunately, individuals of Indian or Malay ancestry somehow have greater predisposition to metabolic diseases. And these were very much similarly reflected in the glycemic, lipid, and the blood pressure profile. I do apologize for this so-called random scribbles. I'm not quite sure where that comes from. So you would see that the insulin levels in the Malay Indian individuals were higher than the Chinese individual. The same goes for triglycerides level. The same goes for the blood pressure. And here are the adiposity that you've seen in the earlier work, which is the same set of the DEXA data. Here is the visceral fatness that you've seen. Appreciate the gap of the fatness. This is in the kilogram per meter square. So that means in kilograms, the difference could be almost 1 to 2 kilograms worth of fat mass. This is quite a lot. So you would see here elevated waist circumference, BMI, and visceral fat mass in Malay and Indian individuals. So what's the main story of this work, of this follow-up work? The main story was that we demonstrate that visceral fat contributes to the health disparity across Asian ethnicity. And this is an important public health message because visceral fat is really the bad guy. It's not only affecting the cognitive function, but it also explains the health disparity in across different ethnicity. And by knowing this, we could then identify the subgroups in our population that is at higher risk of developing metabolic diseases and perhaps apply for example, a lower cutoff of the detection, maybe apply more health screening in the subgroup. So this is a very important public health message, not only to the Singapore Ministry of Health, but could potentially be applicable to South Asian population as well as Southeast Asian population. So I'm just going to go through, this is, I think, my last slide, so please bear with me and then we can move on to the question and answer session. So this figure was taken from the earlier medRxiv, which is the preprint. So what I show here is the results of the regression. This is essentially a regression analysis. Each bar in the x-axis is one regression model. So how do we use a regression model to assess whether the visceral adiposity explains the ethnic difference? You've seen in the earlier slides, right, that the glucose levels are different across ethnicity, drastically different. And the same goes for the insulin, same goes for the lipid, etc. So first of all, if I take the estimated marginal mean of each ethnicity and I plot it, sorry, do I have to finish? Do I have to wrap up? Almost finished. Let me wrap this up very fast, okay? So if I take the estimated marginal mean or differences between the Chinese and the Malay or between the Chinese and the Indian, here, difference between Chinese and Malay is in green, difference between Chinese and Indian is in blue, okay? So first adjust for the age and sex only. So you see the bar because that's the difference. That's what we know. If I then add the BMI or visceral fat as a covariate, would I see the bar disappear? Because if the bar disappear, it means that that difference comes from the visceral fat. If it doesn't disappear, it comes from somewhere else, okay? So what you see here is that the bar disappears after we adjusted for fat, adiposity. It means that in the individuals of Malay ancestries, the huge gap in the health disparity across ethnicity come from the difference in the adiposity. But somehow, intriguingly, in individuals of Indian ancestries, that's not necessarily the case. It does explain, yes, fat is important, but it doesn't fully explain. So it must have come from somewhere else. And this is part of our follow-up work. The findings remain robust when we use alternative measures of adiposity. When we use waist ratio, waist circumference, or fat, it's all the same. When we adjusted for drug treatment, it's the same. When we use untransformed data, it's the same. When we factor in regression dilution, it was still the same. And when we further adjusted for socioeconomic factors, no change in the result, it was still the same. The visceral fat is the culprit. The adiposity is the culprit, okay? So I'd like to end my sharing here. I'll be very happy to take questions. I know that it is quite heavy on a Monday morning, a lot of statistical concept, but I do hope it can be helpful to your study. So thank you very much again for the kind invitation and for this opportunity to share. I'll stop sharing screen now. Fatima, over to you. Sorry, Fatima, I couldn't hear you.
Hi, Teresia.
Yes. Oh, I can hear echo now. Sorry.
Oh, okay. Let me just figure out. Okay. Teresia.
I can hear you, but there is a lot of echo.
Oke. Dimatiin aja karena udah pada sering dari itu.
Hello.
Okay. How about now, Teresia? Can you see?
Excellent. Yes. No more echo. Yes, okay. I can hear you very clearly.
Thank you so much. It was a wonderful and intriguing lecture. I believe it is also an eye-opening.
I hope the students don't fall asleep. I can see
that
the
our
lecture.
Students have already known the relation between adiposity or obesity with cardiometabolic diseases such as type 2 diabetes and cardiovascular diseases, but your study is offering a novel value in entangling how obesity actually also relates to other diseases, and in your case, it's cognitive function, declining cognitive function. So it is an eye-opening lecture for me as well, and I believe also for the students. I can see that we already have some question in here. Any of you joining me in the auditorium? Do you have question?
Okay. I hope they don't fall asleep.
Come on, don't be shy.
I was just saying that it's Monday morning, it's a heavy lecture. I hope they don't fall asleep. Please do feel free to ask questions, no matter how simple it is, please. Fatima, I can't hear you. Sorry.
So in here in the auditorium, we already have one question, Teresia.
Okay.
Trifosa, can you put on your microphone and tell us your question, please?
Okay, can you hear my voice?
Yes,
yes.
Go ahead.
Yeah, I can hear.
Thank you so much for the great lecture, Dr. Teresia. Let me introduce myself. I'm Trifosa Alpasan from the undergraduate of nutrition study program. So my question is, that we have discussed that this research can be a preventive tool, but because it is closely related to genetics, is the effect of adiposity on cognitive function reversible or irreversible? Can we fix the cognitive regression by cutting off the adiposity? That's my question.
Very great questions. Very good questions. Excellent, excellent. So you're quite right to think, oh, well, if it's already in the genes, what can we do then? Should we just resign to the fate? Yeah. um, so I'm not sure how familiar you are with the literature of cognitive training. Okay. So the take-home message is that actually do not despair. Just because you have a lot of adiposity doesn't mean that you are guaranteed to develop Alzheimer's disease in the next 20 years. That is not the case. There are currently several randomized control trials trying to see the effect of BMI reduction or adiposity reduction and whether it can help to maintain the cognitive function or whether it can help to improve the cognitive function. The results so far are still inconclusive, but that's because randomized control trial is always very challenging. And also because the randomized control trial of 6 months is not enough. Sometimes you need to take longer, and it's just very challenging to conduct, and we do not yet have the evidence for that. However, from the literature of the cognitive training, I'd like to share a message that cognitive function is not static. You can train it. It's like muscles. It's like exercise. You could train. You could play Sudoku. I'm not saying that you should play Sudoku, but I mean, there are many different kinds of cognitive training. And it means that it means that just because there is a genetic predisposition doesn't mean you should resign to the fate. Cognitive training is not static, it's dynamic. It can be trained, it can be maintained, it can be improved, even at adulthood. And that is proven.
Okay. Thank you so much, Teresia, for your answers. Triposa, I hope it answers your questions. Okay. And do we have more questions from the auditorium? I can see people in the back. Do you in blue shirt? Do you want to ask question? No? Or shall I ask those who joining us online, our postgraduate students, Damas and friends? I believe you also already have questions for Dr. Teresia. If you have also a speaker problem, you can also type the questions in the chat box so we can read your questions. Well, maybe if I actually want to ask you some questions
Yeah,
as
sure.
well,
Yes, please
Teresia,
go ahead,
if you
Fatima.
don't
Yes,
mind.
it's fine. Yeah, no, of course, it's
Okay.
fine.
So, Dr. Teresia, we saw from your slides that baseline cognitive functions influence to the declining cognitive functions as well as we age, and then also the syndrome, metabolic syndrome, also kind of like predict cognitive decline. But my question is actually regarding the representativeness of Asian populations in studies related to this, because well, in one of your slides you mentioned that the majority of GWAS and MR studies, they kind of like only involve the majority of European people, and also, well, some are mixed, but I'm not sure how representative the study are for the Asian populations. And
Yeah,
also,
yeah.
what do you think we should do as an Asian academics to kind of like solve this problem?
Yeah, yeah. So, Fatima, you've really hit the nail there. It is actually the caveat, really. Some of the reviewers, when we submitted this work, they were commenting, "Oh, such a shame," because the cohort study was from Singapore, from Asia, and then you have to use the MR from European, from the European GWAS, which is a bit of a shame. And that is because we had no choice, because there was no GWAS from Asian cohorts. There's just simply none, or if even there are, there's currently still too small. The good news is that there is a Kaduri Chinese biobank that I think recently published some results. There's also a Japanese biobank. There's also Taiwanese biobank. But you would see that many of these countries are all East Asian origins. There are still very little we know from Southeast Asian community, Indonesia included, as some of the largest population in the world. And then also very little from South Asia, from India. My prof, my supervisor, Prof. John Chambers, is leading the South Asian Biobank, and we are really hoping to sequence more samples. And of course, we have Helios. We are sequencing as many samples as we can, generating our own GWAS study in order to join this international consortia. And I think through time and time again, my geneticist colleagues have shown that when you incorporate the data from different ancestries, the result of the GWAS change. So sometimes the genetic predisposition of certain genes in European may be different in our Asian individual. So what's the take-home message for Indonesian academics or Asian academics in general? I think the message is that to continue collecting data, set up a good quality cohort, engage with the international partners to develop the so-called intra-operationality. Because sometimes here, there may be a bit of a fear, and we experience the same thing as well here. When we were setting up the Helios study cohort, we were thinking, we want to make sure that this can be similar to what the UK Biobank has done. But if we bring in people from the UK Biobank, will they steal our data? So there's always this challenges and conflict. The resources are from Asia. We want to protect our resources. We don't want to share our data. But then we also need their help because they are more experienced. And so there was a bit of a trade-off, of course, even on our level. We seek expertise from the Imperial College London, whose professors have been very instrumental in setting up the UK Biobank, and they are still part of our team. So they help us to develop the study, making sure that the way our study protocol is set is as similar as possible to the UK Biobank. And by all means, I don't mean that, then let's have something like the Indonesian Biobank, because it is very expensive. But no matter how small the study is, the similarity in the study protocol, the way the biological samples are handled and then processed or assayed or sequenced are very important. So sometimes it's important to engage our international partners from the very early on in the study design. We found that very helpful in Singapore.
Okay, thank you, Teresia. And it reminds us, it is a homework actually for us academics in Indonesia to start maybe building our GWAS and MR studies as well. I mean, I think there is still kind of like difficulties or limitations, and particularly in part of in terms of funding, because as we know that.
Yeah, of course.
But
yes.
Your point about engaging to international collaborators is a good inspiration for us, and I think we have hope for our students in here, because well, they will be the next future generations and the next future academics in Indonesia, and after hearing your lectures today, this can be an inspiration for them.
And it's, I just want to emphasize that it's not a competition with the cohort in the US or cohort in the UK, but the key is an international collaboration. So it's not to say that, these Asian scientists must do everything by themselves in isolation, but bringing in the key partners who are sympathetic to our public health issues, that is going to be very helpful. They can guide us, but we own the work. We own the data, and we contribute our data and samples to the global consortia. So I think hopefully, the lecture can help to facilitate that thought in the near future.
It sure is. Thank you, Teresia. Nicely said. Because we only have limited time for question and answer sessions, I would like to greet those who are joining us online. We do have some postgraduate students here with us. We have Damas and Natalia and Tati and other students at the postgraduate program. Do you want to ask questions? Damas, Natalia? Okay. Okay, we have
Okay, I
one
have
question
one.
in the
Oh,
chat
I have
box.
two questions
Oh,
from
okay,
Damas and
okay.
Natalia. Hello, thank you. Okay, okay, because okay, can we also accurately detect the early in the general population? Okay. And then the second question. Okay, let me first address Damas' questions about early screening in metabolic syndrome. Quite interesting questions because there are a whole lot of literature on its own trying to decide whether we should lower down the cutoff, whether we should apply a different cutoff of the symptoms in the Asian population compared to the general European or American population. And the answer is that I think each and every country, they need to look at their own data and determine that. So certainly, yes, you can screen it early. In Singapore, I think there are some works to try to lower the glucose, fasting glucose cutoff, clinical cutoff in the clinic. We haven't gone into the extent of applying different cutoff across different ethnicity. That still requires early days. It still requires a lot of work to prove whether that is first effective in preventing disease, second cost effective. Because as you can imagine, if you tell the doctors and apply different cutoff in different ethnic groups, this is quite complex exercise. So need a lot of study to do that, but certainly possible. There are definitely works on that in Asia as well as international. The second question, also I hope that addressed Dharma's question. Second questions from Natalia. Thank you for sharing a question about specific dietary recommendation on. Okay, I'm waiting for these questions to come. This is part of my current work. Natalia, if I can tell you the answer now, I wish I can. It is still a work in progress. Of course, you will see a lot of works from European literature. Maybe you have heard about alternative healthy eating index, Mediterranean index, blah, blah, blah. There's a lot of different kind of index out there, and how you will see studies that try to prove that if people adhere to the Mediterranean index, then the cognitive functions will be maintained or will be improved. Well, that's fine. That is in the European population. Can you apply Mediterranean diet index to Indonesian diet? I don't think so. They don't even have the rice as part of the components. Yeah. So how can you apply a European index into Asian index? Most of us eat rice. We don't eat potato and pasta every day. Yeah. So this is part of an ongoing work. We are trying to derive and understand our population diet pattern and also food items that is specific to Asian population, and try to see whether which of these dietary risk factors confers the greatest effect on our cognitive health. So this is part of my ongoing work. Thank you. Thank you, Natalia. So is that okay, Fatima?
Yes, okay. Thank you very much, Teresia, for your wonderful answers. I do apologize that we have very limited time for the question and answers.
No
So
problem.
this
No
can
worries.
actually be prevented, haven't we started earlier, but we are so sorry again for the IT malfunction. So
no worries at all. I'd like to say if any of you are happy to contact me, Fatima, you have my contact. I'll be very happy to answer questions through emails as well. So please feel free to share the slides if that helps the student. We are very happy to do that. And so if there's any further opportunity to share, I'll be happy to.
okay, thank you so much, Teresia. And for those of you students who may still have questions for Dr. Teresia, you can maybe share or email your questions to me, and I will submit the list of questions to Dr. Teresia to reach for the answers. Okay, do you mind, Teresia, if I contact you later with the list of questions from the students?
Yeah, that's fine.
Okay, thank you very much. Okay.
Thank you, everyone.
I truly apologize again for the IT malfunctions, but I hope that next time you are still interested to visit us, maybe in person to Depok, Indonesia, because well, maybe it is also nice to know that Dr. Teresia itself is actually she has a heritage from Indonesian origin. So like one of your
Saya bisa cakap Indonesia.
okay, nice to know, and we will be excited if you can come visit us again in person to Universitas Indonesia. Okay, I would like to say my biggest gratitude, my big thanks for all of you who are still patiently join me today through this auditorium despite all the IT malfunctions. So thank you very much for your attentions. I'll see you again. I'll see you again next time for hopefully the next sessions of guest lectures. And also thank you, Dr. Teresia, for sharing with us your wonderful lectures. Well, I guess that's all to wrap up this event. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh. Good morning, Teresia.
Good
Bye-bye.
morning. Bye-bye. Bye-bye.
Okay.
Yes, yes.
Okay.